Hello, Val Andy here, your host for the Insomnia File. Today we have two stories. The first is about an accident more complex than the universe, from former astrophysicist and science fiction author Alistair Reynolds. Let's begin. Let's consider all the inanimate matter in the universe, all the dumb atoms, all the mindless molecules, all the oblivious dust grains and pebbles and rocks and ice balls and worlds and stars, all the unthinking galaxies and superclusters wheeling through the oblivious time-haunted megaparsecs of the cosmic supervoid. In all that immensity, she had somehow contrived to be a human being, a macroscopically tiny, cosmically insignificant bundle of information processing systems, wired to a mind more structurally complex than the Milky Way galaxy itself, maybe even more complex than the rest of the whole damn universe. Reynolds appears to be echoing the great British physicist Sir Roger Penrose, who said that the human brain is more complex than our Milky Way galaxy. If you look at the entire physical cosmos, Penrose says, our brains are a tiny, tiny part of it, but they're the most perfectly organized part. Compared to the complexity of a brain that allows us to exist not just in the moment, but to anticipate the future, a galaxy is just an inert lump. But could it be that rerun the tape of evolution and DNA, RNA, ATP, the Krebs cycle, the entire rigmarole of Biology 101, that life would probably arise again, here or in distant worlds? Single cells would join together, seeking the advantage of metazoan life, until before you knew it, something like the earthly menagerie would come to be again. The human brain contains 100 billion neurons, about the same number of stars in the galaxy. And each neuron connects with hundreds, maybe thousands of others to form a vast network of information flow. Billions of rapid-firing neurons send elaborate cascades of electrochemical signals coursing through the networks. Somehow out of this electrical melee, coherent consciousness emerges. These brain cells are powerhouses of information processing. Each has a fiber called an axon sprouting from its body. It can be as long as 1 meter or more. Axons serve as wires that link neurons together to form the network. It's been estimated that there may be as many as 1,000 trillion connections in the human brain as a whole, amounting to an astonishing level of complexity. Neurons can fire, that is, send pulses down axons at a frenetic rate, maybe 50 times a second. All that adds up to the brain executing about 1,015 logical operations per second, faster than the world's fastest supercomputer. But most fascinating of all is that a supercomputer generates many megawatts of heat, whereas the human brain does all that work with the same thermal output as a single low-wattage light bulb. Looking back over the past 3.5 billion years, the origin of life was the first, the most momentous transformation. However, the history of evolution contains other major transitions, critical steps without which further advance would be impossible. It took 1 billion years or so after life began for the next major transition, the arrival of eukaryotes and DNA. Another big step was sex. Later came the leap from unicellularity to multicellularity. What prompted these epic transformations to occur? Are there any common underlying features? Eukaryogenesis, sex, and multicellularity all involved marked physical alterations. But the true significance lay not with the changes in form or complexity, but with the concomitant reorganizations of information architecture. Each step represented a mammoth software upgrade. But the biggest upgrade of all began about 500 million years ago with the appearance of a primitive central nervous system. Fast forward to today, and the human brain is the most complex information processing system known. From that system stems what is undoubtedly the most astonishing phenomena of all in life's magic puzzle box, consciousness. Our second story comes from Princeton's great quantum physicist, John Archibald Wheeler, who coined the term black hole. Near the end of his life, in his memoir, Geons, Black Holes, and Quantum Foam, Wheeler suggests that when we finally unravel the secret of the universe, of human existence, that we will be astounded by its simplicity. Today, Wheeler says, I think we are beginning to suspect that man is not a teeny cog that really doesn't make much of a difference to the running of this huge cosmic machine, but rather that there is a much more intimate tie between man and the universe than we ever suspected. The physical world in some deep sense is tied to the human being. Being Homo Sapiens, we live on an island, the universe, surrounded by a sea of ignorance, says Wheeler. As our island of knowledge grows, so does the shore of our ignorance. But of all the obstacles to a thoroughly penetrating account of existence, none looms up more dismayingly than time. Explain time, Wheeler asks? Not without explaining existence. Explain existence? Not without explaining time, he says. To uncover the deep and hidden connection between time and existence is a task for the future. The very mechanism of the universe appears meaningless or unworkable, Wheeler says, unless the universe is guaranteed to produce life, consciousness, and human or alien observers somewhere and for some little time in its history. The quantum principle shows that there is a sense in which what the observer will do in the future defines what happens in the past, even in a past so remote that life did not then exist, and shows even more that an observer, a you or me, is a prerequisite for any useful version of reality. The universe, Wheeler says, is a totality in which what happens now gives reality to what happened then, perhaps even determines what happened then. Val Landy, signing off. Remember that science fiction isn't dead, it's just not fiction anymore. Please click on the subscribe button and visit us at dailygalaxy.com. Thank you, and good night.